Dante Certification Program Level 3. In this short module, we will look at why packet-switched networks are used on computers. On computers, we run all different types of applications. Why? Because the network is neutral. Each of these applications have an address. Some talk internally, and others need to communicate externally over the network socket. Picture this. A Swiss flag represents the neutrality of that nation. You can use this as a visual reminder for the neutrality of the network. Here's what happens when you run a session on a computer. First, you open a browser, in this case Google Chrome, and type in youtube.com. The browser tells itself, I don't know YouTube's IP address. I wonder if there's something like a directory. Then it thinks to itself, DNS. I know a DNS server's IP address, which is 8.8.8.8. Let's call them. It reaches Google's DNS server through the public internet. It then asks Google's DNS server for YouTube's IP address. The DNS server looks it up and responds. The browser now takes a note of that IP address so it doesn't have to repeat that request again. Then it asks itself, what is my internal address? It knows the internal address, in this case TCP 53618. It also knows its IP address, in this case it's 192.168.1.23. The browser knows it needs to communicate securely, so it knows that it has to communicate via port 443. Then it calls YouTube using the IP address it was given. The message goes out to YouTube. The message reaches YouTube on its IP address. YouTube now responds asking what the browser needs. Now the browser replies, cat videos please. There, the browser window now gets populated with cat videos. This is what happens behind the scenes every time you run an application on your computer. The same simple form of discovery that's used in this example, that is DNS, Domain Name Service, is what we use for discovery inside Dante to discover devices. To do this, no static server in a local subnet is needed. Dante uses MDNS, that is Multicast DNS, which allows multiple servers to pick up and listen for devices saying hi. Let's look at this example. Here we've got YouTube, Facebook, Outlook, and Spotify. They all have local TCP port addresses and remote port addresses. For HTTPS services, the remote socket will be 443, except for Outlook, which will be using 389 socket for an Exchange server. This is somewhat like a multicore cable. Numbers identifying the pairs in the multicore is similar to socket addresses. Except that in an IP-based system, we have 16 bits worth of addresses per transport protocol. Picture it like a massive multicore cable coming out of your computer that you can pop applications on. Now, similar to how applications have addresses, in audio various applications have their own port addresses. Pay attention to this chart. In Dante, PTP clocking information uses UDP port 53618. AudioFlow uses 14340 and 14350. If you're wondering about what exactly goes on behind the scenes in Dante, picture the cat video example from earlier. It's a good functional example for you to remember the process that happens behind the scenes in a Dante network. To summarize, let's compare IP networks with analog and TDM. Addressing is key to IP networks. In a mail system, all sorts of things go into the mail, but they still get delivered to the correct place because of addressing. In an analog system, dedicated cable was where system traffic was on its own easily visible copper pair. Now, a Tdm system multiplexes different signals together in a higher speed backplane and then demultiplexes them on the other end. As you're probably aware by now, Dante uses IP, whereas older systems used Tdm.